But if you get like a 57.004, you still round up.
You round all the way up to the next number, exactly. All right, that's my argument for today. So you could put, if you want to, you could put, let's see, what could you do? I don't know if you really want to do that. So if you want to, you could put that. I wouldn't put it down. You should just know the process for finding percentile. So if I have a data list, that's formula sheet. This is not. If I have 28 things and I want the 15th percentile, step one would be 15% of 28. Cool. And whatever you get, if you get a whole number, you average that one with the next one. If you get anything else, you round it up and take that number.
4.2.
Cool. So here's 4.2. So you would go up and you take the fifth number. So the second step is go get the answer. Cool. Yes?
So wait, if it's a decimal, you would just go up?
Exactly.
Okay. But
Anything other than a whole number, you go up.
Okay, so then it you do down.
Yeah. So if this would have come out to be 4, I would have averaged the 4th and 5th. Yeah. Anything else, you round up and you take that number. Cool. Okay. Chapter 4 was all the probability stuff. And that will show back up on the final. So you can have all your probability formulas here. Okay. And then it leads into chapter 5, which is all about probability distributions. The one that Brandon was pointing out. Remember this stuff here?
Yeah.
Semi, sort of.
So we can write down the A or B and like all that stuff?
Sure, yep. That's the few words you can use.
Is that minus, for the first one, is that minus the probability of A or B, A and B?
A and B, yep. Cool. This is a big reason why you want to double check these against the actual sections in the book. Just so you make sure you're reading my writing correctly. And again, I would never teach this way, but now that you've suffered through all of my attempts at explaining, you can now look at a problem and say, well, obviously, if they give me x's and p of x's, I want to use these formulas. If they give me, ask me probabilities of doing certain events, I want to use these formulas. So you can kind of tell which formula you use based on what you're given or what you're asked for. This is chapter 5. Chapter 5 concluded with this guy here. What's this for?
Come on, CI.
What was that for? What kind of distribution is that for? Binomial, yes. It's a binomial. How do I know it's binomial? There's two outcomes. P and Q are the probabilities of those two outcomes. Right? Left-handed, not left-handed. Bless you. Sneezing, not sneezing. Cool. What about the mean and the standard deviation for a binomial? Those are the coolest formulas ever. Bless you. Yeah. Mean is NP. Bless you. What's the standard deviation? NPQ. So that's chapter 5. Yes, ma'am?
Could you tell me the formula the book uses for standard deviation for chapter, the first standard deviation?
This guy?
Yeah.
Yeah. Well, there's the other one, which we didn't really use in practice. It was that one. So if you want to use that one, you can. Just a little bit more work goes into that one. This one is just a little bit quicker.
Okay.
Cool.
Thank you.
You're welcome. Chapter 5. Chapter 6 goes back and uses this guy. But he does introduce the idea eventually of this guy. And that guy would be what now? Be very careful.
Oh.
Be very careful.
Sigma over.
This is standard deviation for a sample of size, whatever, right? The standard deviation of a bunch of means. It's not a sample standard deviation.
Sigma over the.
Yeah, it's the all-1 divided by square root of n. Be it sigma or be it s, I don't care. I have to change the standard deviation from individuals to groups.
Is this chapter 6?
Yep. And this came from what theorem? Say again? Not chubby dude.
Oh,
The thumb theorem.
It does start with a C.
the control.
Oh.
Control the world theory. Central limit theory.
That's
Central limit theory. All right. I'm crying inside a little bit, but we'll show this. All right. Let's see now. So we got through section 6.5. 6.6 was all about the NAB. Remember the NAB? No? Oh well. That's too bad. Who remembers what the NAB means? When I say use the NAB, I know, I'm so sympathetic. My students need help, that's too bad. So, who remembers what the NAB means? When I say use the NAB to do this, what's this fundamental change you gotta make, the adjustment you have to make?
Continuity correction.
Continuity correction, when you go up or down by a half, right? Because then you're dealing with discrete data, which you're trying to pretend like it's continuous. That's why it's called the NAB, the normal approximation to the binomial distribution. Ugh.
Wouldn't that be nabbed?
Don't get so particular. Let me think. So that 6.6 was the NAB. There's no real formulas for there, it's just an idea. When do I do this? Yeah, the formula again gives you a hint. Whenever I take a sample and I ask about the sample means, I have to change standard deviation. So chapter 7, chapter 7 has that built in. Oops. So there's all the formulas from chapter 7. The 3 possible confidence intervals, and then the 2 possible ones for the sample size you need to do something. All right. And then we hit chapter 8, which is basically using all the formulas we've already talked about. The only new thing sort of in chapter 8, if you want to put it down, is this 1 z-score. That. That's really the only new thing in chapter 8, formula-wise.
One of the boxes?
Yes, the one in the box, sorry. Alright, cool. So if you have any suggestions on any formulas I missed.
What's the formula for p-hat again?
Oh, yeah, if you want to do p-hat, where's a good place for it? P-hat equals x over. And that's another optional one. I know how to get a probability, a percentage from a sample. I just take the part divided by the whole. That's really all that's trying to say. Sometimes people get tripped up by formulas because they try to remember, well, what goes here and what goes there. No, it's just a percentage. If I talked to 80 people and 7 of them said something, that's 7 out of 80. Just make a percentage out of it. That's all that formula needs. Yeah.
For the ones where it's like NP, NQ, and then that formula that you just put up there, P hat minus P, what is the difference between P and P hat?
So we know.
Yeah.
P hat comes from a sample. P represents a population. So this is a statistic, whereas this is a parameter. I love it. This describes a sample. This describes a population. Same way X bar, he's wearing a bar on his head. X bar represents a sample. Mu represents a population. Cool. All right. Yes.
I remember something about trying to find the simple standard deviation, and how the formula is slightly different between a sample and a population. I think in the sample you have to subtract 1 from the end or something.
So that was from chapter 3.
Yeah. Sorry.
And that was when you divide by n minus 1 versus divide by n.
Yeah.
Yeah. So that's from way back then.
Yes.
Yeah.
And
We don't have to worry about that now.
so
That's,
even if it's key, it could come up.
oh my God. No, I think I would know.
Okay.
I'm making my final, not somebody else.
All right.
But back in the day, this was one thing, and this was the other possibility. Oops. And we had this discussion about what n-1 was all about. Really it boils down to, it's just an adjustment because all these would be a little bit too small, so you divide by a little less to make them all a little bigger. And then it actually targets the true one better.
And what do we use instead of those?
Now we get these from the calculator. You don't have time. We got a lot of other stuff to do with them. So I made you suffer through chapter 3, which is where you did this by hand, so you can kind of see what goes into it. But now you just get it from the calculator. 1 bar stats, right? So you have population, you just get sigma from 1 bar stats, or S from 1 bar stats. Yeah.
Wait, so now on the final, can we do it with the calculator? Do we have to show, are we gonna have to show?
Ever since the chapter 3 test, you haven't had to do this by hand, right? Ever since then, you could use a
This seems
calculator.
like a long time ago.
I know.
Seems so long ago.
Actually, it's weird. Feels like just yesterday I was taking roll for the first time and it's already freaking over. All right, anything else from the map formula sheet? Any other suggestions for it?
So wait, so what is this one again? I'm sorry. Are we allowed to have this one?
You can, but you don't have to use it, so
Oh, okay.
I'd say don't do it. Don't.
Don't.
Hopefully it looks familiar. All right, so that's the formula sheet you can use. So you can either make a new one or just bring in all the old ones you used. No problem. Let me go ahead and give you guys the answer key for the practice final, and then we'll just, whatever you guys want to do, examples of something or any other kind of problems you want to do.
How many questions are on the final? You haven't made it yet, huh?
Normally about 24 to 28 questions total. And you know when I say that, I mean I'm counting all the A, B, C, D, right?
You are or you're not?
I am. Because I hate it when you ask the teacher, how many questions are there? 4. And they're all A through K. It's not 4 questions. Yeah, it is 1, 2, 3, 4.
So all of them are 20 plus.
So about in the mid-20s normally. Because the final, we have a little more time for the final than we have for any other test. So the final's going to be just a little bit longer than a regular test. The pre-calc class, we normally have 3 hours, and now we have 2. So that makes your final smaller, actually. Yeah.
We had ACE in the first chapter.
Say again?
We had the ACE questions in the first chapter.
Oh yeah, you could. All right, guys. So, what do we want to focus on possibly here? Yes.
Just like, I realize I already have the practice final, but if you could just like work through the like one from each, like a similar question. Each things on the practice time.
I like your questions. Very broad ranging.
Yeah, that's why I
You
know.
can just do an example of everything that might be on the final.
Yeah.
Thank you.
That's it, yeah.
Can somebody help me narrow it down a little bit?
Well, we can start at the beginning with the
Everybody got this here? The way I normally kind of like to do this, and let me know if you like it or not, I normally have to go kind of backwards. So I'd start in chapter 10 and then work back. We don't have to do that, but it seems to work pretty well. You guys don't like that? Yes? No? You guys are ambivalent, as always. I will not let you know at all how I feel. Yeah.
Oh yeah, the choosing.
This here.
Oh, yeah.
that's what I was talking about.
Okay.
1.788.
Wait, that's chapter 4?
No.
Chapter
it's
5.
1. It should be a 1. Do this
So,
now.
Which one are we doing? Chapter 5.
Do
Oh,
1.
yeah.
It's
Yeah.
0.8212.
Yeah.
so chapter 5 kind of problems.
I got this in here.
So let's say 72% of gross month students have not started Christmas shopping yet. I can't even think about Christmas at the moment. So 72% of gross month students have not started Christmas shopping yet. We take a random sample of 154 gross month students. Find the probability that exactly, what, Jeff? I don't know. 128 have not started Christmas shopping yet. So, this, I'm obviously not going to say on the final, okay, this is a chapter 5 problem. You should use the binomial formula. Here we go. No. So I'm just going to give it to you like this. What jumps out at you here, though, is there's a percentage of something happening. So obviously there must be a percentage of that, the opposite thing, right? There's an n here. I'm asking a probability of x equals something. So I got p, q, n, x. That sounds like what I need for that binomial formula, right? So these kind of should jump out at us at what kind of problem this is. So let's kind of summarize what we got. What's n?
154.
Good. And what's p? 0.72, I love it. What's q?
28.
2.8, I love it. And then x in this case, of course, is right there, staring me in the face. So now I just got to set this bad boy up. How does that formula get set up? Yeah, I got 154 people. I want to choose 128 of them. So then how many successes do I have? And how many failures do I have? How many successes do I want to have? You already told me. 128. So then how many failures do I have?
Oh,
Minus that. That 20 is minus,
number.
minus 1.
26. Cool.
Where are you getting the 26?
Oh, that's the right.
If 128 successes and there are 154 people,
Subtract from that.
Wait.
what's left? So what's always got to be true about these two powers? They have to add up to be n. Yeah. Because you're cutting your group up into two people, two types of people, successes and failures. Yes, sir.
That's, I'm not sure if I'm looking at it correctly. That's not raised to it, right? The 128 isn't raised to those two things.
Do it again.
For the raised. Are those supposed to be next to each other or above the other? You have 154 choose 128, and then you have the 72, and that's supposed to be next to it. That's multiplied by 72, not
Yeah.
raised by 72.
No. So you can multiply if you want to, sure.
Oh,
All
okay.
How do we do that on the calculator?
right.
Wait.
Math, probability,
Up up here.
NCR.
Whoa.
No, but I noticed that you did this wrong, so.
All right, it's
That
different.
would be like an indicator to like.
And depending on how they do it, you might have to put in the 154 before you do that.
Yeah,
This
just
is true.
put 154 and then
Oh.
NCR.
Yeah.
That's okay, I don't have any idea
Sometimes they
what's
give you like a supplemental, depending on the calculator.
Let's see. Whoa. We got a brand new projector just in time for Christmas. Class to be over. I love it. Oh, they're awesome.
They said it, let's get it this night.
All right, guys. Oh, all right. It's a brand new projector. Just kind of. So remember on the final, just like any other test, if your calculator is freaking out, don't freak out yourself, just come up and tell me, I'm not sure what's going on here. Because if it's in the wrong mode and you try to graph something, it has like measles, there's a bunch of dots show up and that freaks students out. It all depends on what you were doing with the calculator before. So if you're borrowing it from me or somebody else, you never know what kind of weird settings it might be on. Who remembers a shortcut for this? All right, we'll talk about that too. All right. So here's how you do this. You put in there 154. Where's choose at?
Math.
Good. Math?
Probability.
Probability. And there's number 3 is choose. 154 choose 128 times 0.72 to the 128 times 0.28 to the 26. Okay, very small. How do I interpret that? What does that mean? Ooh, look at that. How do I write that as a decimal? Yeah, it says move it back 4 places, right? So it'd be 0, 0, 0, good. 4, 6. It's a very small chance it's going to happen. Cool, man. All right. So don't put down 4.6. Like greater than 1, holy shit. The probability can't be greater than 1 decimal. So that's no good. The shortcut for this, you don't have to know this. Go to second vars to get up into distributions. Then you can go over to binomial. Which one do I want? Nope. I want a particular value, not a cumulative. I want a particular. I want it to be exactly 128. And the input is just n, comma, p, comma, x. And thankfully, not surprisingly, it's the same answer because that's what the calculator does. The calculator just does that formula.
And how did that,
How do you do the first part of that?
Oh, second vars, yeah. Someday these will work for me. Neat. Not yet.
they have those, you just don't have it.
Yeah, we just don't have it.
Wait, so is
Yeah,
it
minority report kind of things.
To the binomial PDF, or
Say again?
you go to the second and vars, then the binomial.
Yep, so
PDF.
second vars, and then it's down. So I just hit the up arrow to get to it quicker. And then there's binomial PDF. Again, I don't want to see the answer come out of nowhere. You have to show me this. Now, if you're really smart and you realize you have trouble with this sometimes, put it in the calculator, set the formula up, and then just do binomial PDF. Now, you better hope that this formula is set up correctly and actually leads you to the right answer. I'll be like, where the hell did that come from? You kind of understand what I'm saying? So you probably want to know how to put this in the calculator just to make sure it's actually set up correctly. You can double check yourself using the binomial PDF.
But wasn't the answer like 4 point? Because I got 4.600.
Yep, that was the answer.
And, which order
Yes,
is
so
that?
So the answer was here,
Yeah.
and that's what we got for binomial PDF.
And so it's.
Same thing.
So then wait, how am I getting it to?
Because it's times 10 to the
So it's,
negative 4. So move the decimal back 4 places.
Oh.
so,
So we have to be ready for those really, really improbable events. You're going to have very small probabilities. So you got to be ready for that. What's the mean in this case? What's the expected value? What's the formula for the mean in this case?
0.72 times 154.
Yeah, NP. So it'll be 154 times 0.72. Somebody help me out there. So again? 110? 0.8?
0.88.
88. Okay. What's up?
oh, that's right.
Cool. How we doing?
Around that.
Now, obviously, you should be ready for this. This will probably be a part of a problem where part of the next step would be a NAB problem, right?
We do an apple.
Sure.
don't round the mean, do you?
Do it again, sorry.
Do you round the mean in this situation?
No,
Okay.
a little bit's fine, you don't have to take it out 18 places, take it out a couple places, yeah.
Can we put the binomial PDF formula on the formula sheet?
It's not a formula, so no.
Well, I mean, we can switch it out for, what would it be? It would be for n and p and x, couldn't we?
It's not a formula, so
But we
no.
can make it one.
No, you can't. It's a calculator command.
Yeah.
So what's my bottom line there? No.
Oh.
Yeah. So let's say the same situation,
You can't have.
but now I wanna know what's the probability that,
This.
less than, or say this, more than 128 for that situation there. You with me? Now, I definitely don't wanna do
Exactly
a
120.
bunch of formulas for this, because I have to do it for 129, 130, screw it, no. So this is where I'd want to, and I'd set you up again. I'm not going to suddenly be really evil. I will say use the NAB too. You just have to know what the NAB means. So we got the mean already. Oh, this sucks. I got a 3-hour class later. I'm not sure how long my voice is going to have. I got the mean already, right? The.
You should drink warm tea.
And I say to myself, somebody. Well, that's when I go to karaoke, that's the first thing I do. And I say to myself. I mean, we are.
Yeah.
All right. What's the standard deviation for this case?
110.
It's 110, not 10.
Oh, 110, thank you. Yeah. What's the standard deviation? What's the formula?
Root NPQ.
Beautiful. Square root of NPQ.
Wait, so are you giving us NP as 110.88 or are you?
No, it's the same problem. Same setup.
Oh, I see.
Part A was exactly 128, and part B now is greater than 128.
Oh.
So P was 0.72, Q was 0.28. Somebody help me out there.
Me.
What, sorry?
5.57.
5 point, 5.571? Okay. Don't lose points now on standard deviation. You know you gotta go at least 3 places. Don't make me do that to you. Now, before you start making z-scores, how do I know it's about normal? What do I have to check? I haven't really checked yet. Yeah, NP is 110.88. That's greater than 5. What's NQ?
40 something.
That's true. 43.12, yeah. And that's greater than 5. Is that cool? Again, I'll do it just like with a test. I'll have that be a separate part. Check NP and NQ.
Yeah.
And you got to tell me what it means. It's greater than 5. That means it's normal, so that we can actually do something. The mean was 110.88. My question is greater than 128. When they ask you to use the NAB to do something, that's my clue to you to put that little box on it. If I want greater than 128, do I want to include 128?
No.
No.
Or the no's win. Right? I don't want to include 120. It's not equal to 128. Yeah.
So you're going to tell us it's using that?
Yeah.
Okay.
Just like on the last test. Or the whatever test this was on. So do I want to start in the back or the front?
Front.
Front. So I don't include the 128. So where do I actually want to start then? 128.5. So that's the only adjustment I have to make. I don't change 128 to a z-score. I change 128.5. What does that actually do? It makes the approximation much, much better. This is the step that says, oh, it's not continuous, it's discrete. We got to pretend like it's continuous. So I have to use both sides of the box and then say which side do I actually want to start at. That makes the approximation much better. So now you just make a z-score out of that bad boy. So our data point minus the mean divided by the standard deviation. Comes out to like 3.3. That's close. How are we doing so far? How are we doing? So I desperately, this is how I try to teach this. If I'm trying to use the z-scores to find probabilities, I pretty much always have to have this little verification here. Either they gotta tell me it's normal, or the sample size is big enough, or in the case of NPQs, NP and NQ have to be bigger than 5. If they are, I know it's normal, I can then get a z-score and look it up. And this whole process of making a z-score and looking up, that should be almost second nature now. We've been doing it so freaking much, I'm hoping that it's like, no problem. I get the z-score, how do I look that up? Oh, sorry.
You're always gonna go up by 0.5 or down by 0.5?
No. The only reason I went up is because I did not want to include 128.
Yeah.
If it had been greater than or equal to, I would have wanted to shade this in, I would have started here then, to include it.
But if you do have to go up or down from it, then it's always gonna be by 0.5?
Well, always by 0.5, yeah.
Okay.
Sorry, that was your point, okay.
Yeah.
My point was don't try to memorize it, just look at the case, but your point's right, only by 0.5. So when you look up 3.16, what do you get from the z-score chart?
Like 9992.
Good, and that's where?
Oh, down.
3.16, right. Yes, this is 0.9992, so what's my answer gonna be then? Yeah, 1 minus that, so 0.0008. Alright. So that's an example of the nav. Okay, cool. Maybe, yeah.
Quick question, how you have like, is greater than 5, and then when you check it, which one's greater than 30?
That's if I have a mean and a standard deviation problem, and they don't tell me it's normal, then the sample size has to be bigger than 30. And that's from central limit theorem again, right? Yeah.
So the nav is 0.0008, like that's the answer?
Yeah, that's the approximation for this probability. Yeah.
When you're saying 1 minus x, are you minusing the 128?
1 minus x.
We
Where?
were saying x minus 1 or something.
No. When I looked at this z-score, I got this area below it.
Okay.
But how do I get the area that I want greater than, I gotta do 1 minus that, of course, to adjust it, right, for the other side. Okay, and that idea should be old school now, yeah.
Can you put that like in English? Like the problem, like what are they looking for?
All right, so it could, I understand what you mean, that's a good question. So
Okay.
I might not ask you this, I'd say, what's the probability that more than 128 students have not started shopping yet? So that's how it looks in math, right? More than 128 is greater than 128.
And at least would be.
If I said at least, it would be greater than or equal to.
But you can't solve that with the stuff that comes in the later chapters, it has to be solved like this?
What stuff in the later chapters?
Like
I feel
what
like,
we've just learned, like chapter 7 and chapter 8, those sort of things.
Well, chapter 7 will be creating confidence intervals, so they don't really give me probabilities.
oh, okay.
They use probabilities. Chapter 8 is testing claims, and there's
Yeah, I
no
was
claim being made
Chapter
here.
8,
Yeah.
but like, I don't know, I was thinking maybe like chapter 6 or 7.
So this is a chapter 5 problem being done with chapter 6 stuff.
Oh, okay.
Yeah, cool.
Right, so, and then the sort of the same thing with the first part at least. So that's saying that 1 or 4 thousandths or whatever that is, that's the chance that 128 people out of 154 haven't started, even though it is,
Yeah, the probability exactly 128 out of 154 students.
okay.
Exactly 128.
So
So
that's why it's-
it kind of makes sense that it would be such a small probability, right? The chance you're going to get exactly 128. That's why this one's a little bit more fair in a way. The probability of more than 128, at least it gives you an area. Now it's not exactly 128, it's this whole area of more than 128.
And the probability would be 3% probability that there's
0.08%, yeah.
0.08% that there's more. Right, because we did that with that, okay.
Yeah.
Do you want us to put in percentages or?
Either way is fine. You can leave it decimal or percent. Yeah.
And that would be the probability that they have, right?
Yeah, it's all about not started shopping yet, right?
Right.
That's what it's all about. So that's the probability that more than 128 of them have not started shopping.
So if it went down, would that number also, okay, actually, I'm sorry. If it was less than 72% that had, the 72% you gave us,
Yes, yes.
if that were a lower number, like 50%, how would that affect the answer?
Let's not go there right now. That actually sounds like a good bonus question I could ask. And I don't want to focus too much on bonus ideas right now. I appreciate your question, but let's not go there at the moment. Stick with some more nuts and bolts stuff. All right. So now, where to? What else do you ladies want to take a look at? Yeah.
You have 3D.
Or just, 3 in general.
All right. So hopefully the first part of 3 is okay. That's where you can put it into L1, L2, and then do your stuff to get L3, L4.
No.
Okay. So for number 3 on the practice test. So in L1 I could put all the x's. And in L2 I could put all the probabilities. All right, and to be a probability distribution, a valid one, what's got to be true?
Yeah.
Yeah, add up to 1 and
Less than.
between 0 and 1. I like that. All right, so that obviously those do that. So that's part A. Probability x greater than 3. You could either just add up all the ones that are greater than 3, or just do 1 minus 11% for 3. Right. So what's probably that 6? I get a 6. What's probably I get a 6? 13%. So don't make it any more than that. Nothing more complicated at all. Those are the probabilities of those things. Period. And that's why we give it a P symbol. Cool. How do I get L3? Yeah. I want to take all the x's that are in L1 times all the p of x's in L2. And so you can double check it's the numbers I got there. Not surprising, it's exactly how I did it. And then L4, how do I get those? Yeah, Patrick.
L1 or 2.
Can you explain why the pawns on when
L1 times L3.
or not?
As soon as I'm done with this one.
Alright.
Cool.
L1 times L3.
Yeah, you can do L1
times L3.
times L3 to get x squared p of x. So you can double check me there. Cool.
It's asking, prove it's a valid probability distribution, and p of x has to, each one has to be, okay, I see that, I think I got it. All right, thank you.
So part A and B we did. Now part C says find the mean and the standard deviation. So where's the mean come from?
How do you add up all like the row again? I forget.
You ready? I'll show you the ultimate shortcut. To see if you guys can handle this. You could do the whole list and math and sum and all that kind of crap. Here's the ultimate thing. I go to stat, calc, 2 variable stats, and then I just do L3 and L4. Because one thing that one var stats does is it adds up everything in the list. You with me? So here I'm asking it to do 2 things at once. Add up all the things in L3 and L4. It's going to give us a lot of information, but which one means the sum of the stuff? This guy. See, that's where I got the 5.77, right? Do you guys see that? And then if you look at the sum of the other one, that's where I got the 35.41. Now, if you don't like that, you could still do list, math, sum, L3. So you get your 5.77. And then I would hit second enter, just bring that back up and do L4. And there's your 35.41, right?
Wait, can you say that one more time? I'm sorry. Second stat.
Yeah, second stat, math. Number 5 is sum. And then you just put in whatever list you want to add up. Cool. So if I put it in list 2, it would come out to be 1, of course, because I'd be adding up all the probabilities. Okay. So now you can just throw that into the formulas to figure out the end. Let's see. So in part C, you can see the mean is 5.77, because that's the sum of xp of x. And then how I get the standard deviation? I take the sum of x squared p of x minus the mean squared, and then take the square root of that. So you can see that happening here on the answer key. Yeah.
Sorry, when you did the second bar stats, you did list 3 and list 4. What was list 3 and list 4 for? Like, why did you use list 3 and list 4?
Oh, because list 3 and list 4 are where xp of x and x squared p of x are. What do I need for the formula? The sum of xp of x and the sum of x squared p of x. And that's why I did 2 var stats on those two, because one thing that variable statistics does is it sums up the stuff in the list. So it's a real quick way to get both sums very quickly. Yeah. Yeah.
So when you ask it on the test, you'll give it to us just like this. It'll be for the distribution to the right, and then that, and then all those things won't be like some word problem we have to figure it out on our own.
No.
Okay.
Yeah.
Can you go back to
Yeah.
All right. So part D.
Yeah.
Part D. We now know our mean. Oh boy. You guys are lucky. You're my first class. You had me when I still had my voice. We know the mean is 5.77, right? And the standard deviation I worked out to be 1.455. Is that cool? So that's from doing the square root of the 35.41 minus 5.77 squared. That formula. So if I ask you within 1 standard deviation, I want to go up by how much?
1.
Not by 1, but by 1
Minus.
standard deviation. So 1.455. So if you do that, you get 7.225 and 4.315. Now don't make this more than it is. What numbers are in between there? Yeah, 5 is in here, 4 is not in there, 5 is in here, 6 is in here, 7's in there, 5, 6, 7. So then you just take the probabilities of those and you add them up.
And you get 35%.
And you get the percentage of the data that's in there. You have all the 5s, all the 6s, all the 7s are in there. So 12% are 5s, 13% are 6s, 50% are 7s. You add those up. Yeah.
If you would, how would you have asked that question? What was the probability of the numbers to lie inside, or?
I would ask it just like that.
D on number 3.
Yeah, number 3D.
Because you could also say what percentage of it lies inside, right?
Sure.
You would have to take 3 numbers over 7, or 3 over 5.
You couldn't do that. Definitely not.
You couldn't do that.
No, because not all the data points are equally likely. The most likely data point is 7.
Not the probability of it. I mean, like, what percentage of the numbers are in there?
I got you. But again, there's not a single 3, a single 4, a single 5. 11% of my data is 3s. 14% of my data is 4, so forth. Is that cool?
Yeah.
Yeah.
So then it asks about if it might be normal. So is that assuming the 95% rule?
No, well, no, not 95%. We only went out 1 standard deviation. There should be what percentage? 68. And we got 75. So could that be normal? No, that's pretty far off. Right. Yes,
I don't see how 5, 6, and 7 fall within the range.
It's got to be between 4.315
Okay.
and 7.225.
Wait, so it's not normal because there's more than 68% out of the
Yep.
Wait.
But the probabilities of them were like 0.14, like.
I like it. Cool. So this is all about data points.
Okay.
You see what data points are in there,
Yeah.
and then you go see what percentage you just caught. So what did we catch number-wise? We caught
Oh, I
5,
see how, like,
6,
okay.
and 7.
Okay.
Now what percentage did we just catch then? Yeah.
Okay.
So if I caught all the 5s, all the 6s, all the 7s, what percentage did I just catch? I have to add those percentages up. Cool.
And what is the percentage markers for being normal? Again, because there was like 68 and like 97 and
95.
Wait, so
yes,
how much?
what are those?
What do you mean, what are those?
Like one of them.
They are.
Well, I mean, but there's more than that, wasn't there?
Yeah,
So how
and
much
to tell you honestly, we're past that point now, right?
How much away from
We are so
60?
much better now than the empirical rule. Empirical is really old news. It's on here. So we've gone way past empirical rule now.
Right.
But how
This
much,
is beefed up empirical rule.
how much past 68 do you consider it not normal?
That's where we start doing tests. That's where you start doing hypothesis tests. And that would be in like statistics 2, where you start saying, does a given distribution, is it close enough to some distribution to say it is that?
Well, like if we had this 3D on the test, like I would consider 0.75 to be normal enough, but I guess not.
Well, it's
Like,
definitely
I have
not
no
close to
criteria.
68. Right, it's obviously not close to 68.
And-
There's no way.
But I mean, the Z-score chart doesn't tell us which numbers are the benchmarks for 68. And, so you said it was 68 and 95,
That's empirical rule, yes.
and that's for one.
So I appreciate that some of you guys are trying to get into bonus territory.
No.
There are tests called F tests, where you see how far a given distribution is away from what it would look like if it was exactly normal. And they say, okay, it's close enough, and you do a hypothesis test like we already have done.
But you're not asking. Will you?
Definitely
ask
not.
about
I'm just
how-
saying, what does empirical rule
Okay.
say? For it to be normal, what percentage has to be in there?
That's what I'm
Exactly 68. Was there exactly 68?
No. Okay.
All right.
That was the
Not
question.
normal.
All right.
Cool.
So it's 68.
Okay, so don't make more out of it than it is. This is stats 1. Not stats 2. Okay. No, but again, I don't want to make you guys feel bad, because it's good questions. And
Well, just because it was on the practice test, so that's why I.
but at this point, I could just, it's an absolute statement for empirical. It
Yeah,
must
no.
be 68%.
All right.
Okay.
And
And
if
it
you
was
were-
absolutely not.
And you wouldn't ask for two standard deviations, which would make.
I could.
95
Certainly could.
or 97.
95.
Where's 97 coming from?
I have no idea. There's 99.7.
That's what it is.
All right.
What is that?
That's 3.
That's 3. Okay.
So anything else we want to focus on? Yeah.
I have a question for the math test sheet, problem 4, part
Let's see, test 2. We have a test 2. Which,
No. All the numbers.
thank you. Which number, Patrick?
Problem 4, part
Part
D.
D. So that's a NAP problem. We already did a NAP problem.
Well, I'm just confused on it.
Okay, but you're specifically confused on that problem, right?
On that part.
Okay. So if we want to do another NAP problem, we can. Or you can come see me after class. Yeah. We could do another NAP problem, it's not a problem. Or we could do anything else that you guys want to do.
All of them?
All of them?
I did.
Could you, number 5D, like, the prediction?
Number 5.
Yeah, all 5.
Mm.
Okay, never mind, I got it. I didn't realize I was supposed to.
Oh, yeah, I totally forgot. Real quick, before I forget. On some of your tests, and this didn't really seem to affect anybody's work, but on some of your tests, I switched the columns. One was number of same-sex households per 1,000, the other one was for Obama. And the ones that were voted for Obama should have been the bigger numbers.
Oh.
You guys kind of went through. It's really interesting that is true data. It is true data. I figured I should do something for both. I did the Romney and the educated level. So I wanted to do Obama, and one of his target demographics obviously would be those people interested in same-sex rights, right? So I wanted to show you that. his correlation was actually a little stronger than the Romney versus how educated people are. But I forgot, one more time, I forgot to bring the actual spreadsheet to show you. I think I did. Yeah, it's back in my notes. So this is number 5. This is that correlation problem.
So,
All right. So first thing is, how do I get the R and the line of best fit?
Stat.
Yep. So go to Stat,
Go to stat.
Calc. Number 4. It's kind of a giveaway, right?
Yeah, 4.
Again, if on the test, if your R is not showing up, just come tell me. I know you guys had trouble and you weren't somewhere you could get to me, but
Are we gonna do the same thing on the test and come up and show you
Yep.
later in line?
do the same thing you did on this last test. You'll show me your line of best fit. So the line of best fit up here is, what is it? What's the equation?
Negative 2.86.
And where did you get one round?
8.6.
Any of you guys ever ate at Bronx Pizza?
Nope.
Yeah.
Would you not agree that it's the freaking yummiest? I used to say they must sprinkle their pizza with crack or something. I don't know. I was a data point on here. Thankfully, I'm actually not as big as I used to be because I've moved away from Bronx Pizza for a while. So, what does this R tell us? How would you interpret that? Yeah, it's not a large sample. It's a decently large sample. That's definitely going to blow away any required R. So it's definitely a correlation. What kind of correlation? Strong. Negative. Cool.
And where did you get Lin Mark again?
Say again?
So
So it's under Stat, Calc.
Oh, there it is. Alright.
Yeah.
Why would it be strong negative if it's not a negative number?
It is.
Negative 0.90. You see the negative?
Oh, I didn't see that.
Yeah, R squared is one thing. It's actually used for something that we haven't gotten to yet, but we're not going to get to, obviously. But R is the one that we can immediately use. R squared is kind of nifty because R squared is actually the percentage of the change that can be explained by these two variables. So 82% of the change in your weight can be explained how close you live to Bronx Pizza. Obviously, I made this data up. Hopefully you understand that. I was the only real true data point on there. And now that data point itself has actually changed. So, now how do I get my line of best fit to show up?
Why?
Go to y equals.
0.
And then put in there the negative 2.87x plus 218.58. Now, the graph, it's probably not going to do much of anything. What do I have to hit before I zoom? 9. Zoom stat. There you go. That looks good.
Which one are you?
Huh?
Which one are you?
Let me see. I was unfortunately at that time I was the 216 and the 1.5 miles away. Thankfully now I'm like 20 miles away and I'm more like 203 or something. So, all right. And real quick, on that question about if you increase the number of same-sex couples in your state, would you increase the number of people voting for Obama? No. Well, you can't say it. You can't say definitely no. You can't say definitely yes, because all you've shown is that there is a relationship between the two. You don't know if one causes the other, or if they're both caused by something else. Right? You with me? There could be some third variable I haven't even thought of that makes both of them rise or fall. I don't know. Yeah.
So I'm not sure I was looking right. I managed to do the question relatively correctly. But are you saying that in, let's say, Connecticut, out of every 1,000 people, 581 of them or out of every 1,000 households, 581 of them are same-sex households?
Now, hopefully, remember, I switched two columns around, so the bigger number should be under a comma.
Oh,
That was my mistake, because I was trying to make 4 different versions of the
Yeah, I was
test.
confused about that too, I was like.
Good. Should have been.
that's a lot of.
So it's a smaller number, that's the self-reported same-sex households. All right, guys, guess that's about it, so. Don't forget my office hours are on the grade sheet, the new ones.
So I'm gonna be taking it in the assessment, so how am I gonna show you the
You're gonna make a sketch.
Okay.
You're gonna make a rough sketch of it.
Okay.
I think I'm missing like between 5 and 6. It's just over the course of this
There it is there. And of course, the right one, you have to put
I don't.
Oh. Huh? Wait.
I can.
I have my work testing and the research spreadsheet in your office. And
Oh, yeah.
what we do, we also that problem and I just send you.
Okay, sure.
Probably afternoon.
My test, Brandon.
Yes.
And then are these final?
The answer keys.
Let me know when you're ready. 707 area code.
Mine?
Mine is
All right.
480.
I'm supposed to on Wednesday to make up the test, or is it should
I think,
17.
at this point, oh, good. And you,
I want to do my cap test too. No, I make cap.
I know, but you can go this year. Mercy, right? So let's do this. I can give you the option of either, I have a Thursday, 7:15 a.m. final, I'll give it. So you can certainly make up the test then. Or I can just count the final for a higher percentage of the grade to cover for the missed
Good name?
test.
Aaron? A-A-R-O-N?
How high?
So I'll let you think about it. Just
Yeah.
email me before
Yeah.
Thursday with your, and then I'll tell you where we meet and all that kind of stuff on Thursday. Okay.
Thursday 7:50.
Yes. Oh, yeah.
For this one, I don't have a stapler, so I just do it like this.
I did have a staple. Oh, yeah, that's right.
Whatever you think.